Welcome back to the second part of our Math Minute Madness for Tuesday. We are looking at Math Minute 14, so if you'll have that available to you to make sure that you did things the way you were supposed to, let's check out the answers. In the number 1,846, the blank is in the tens place. So I have ones, tens, hundreds, thousands. So the tens place is the 4. So the 4 is in the tens place, and the 8 is in the hundreds place. So again, you have ones, tens, hundreds, thousands. Which of these shapes best represents a cube? Well, this looks like my Pringles can once my kiddo has finished eating all of the Pringles. And I know that Pringles come in a cylinder. They're the only chip that I can think of that comes in a cylinder. So this is my Pringles can when it's done. This is it when it's still full. So this is also a cylinder. This is what my Amazon boxes normally look like. This is a rectangular prism. And the word prism, P-R-I-S-M. And that leaves letter A to be my cube. Kind of looks like a jack-in-a-box. Circle the fraction that is not in its simplest form. So I have 5/11ths. I know that this is in simplest form because they share no factors. I have 5/15ths. Oh, 5 can go into any number that ends in a 5. So this must not be in simplest form. Let's double check. 5 goes into 5 one time. And whatever I do to the top, I must also do the bottom. 15 divided by 5 is 3. I could still further simplify 5/15ths to 1/3. So this is the fraction that is not in its simplest form. 5/12ths is in its simplest form. Again, there are no factors between the two. And 5/18ths, there are no common factors. So we know that those 3 are in simplest form. If 2/3 equals A over 15, then A equals, this is what we would call an equivalent fraction as well as a proportion. We keep the proportion the same, meaning we multiply or divide by the same number on top and bottom. So 3 times 5 will give me 15. Whatever I do to the denominator, I must do to the numerator. So 2 times 5 is 10. Therefore, A equals 10. We have another early algebra problem for you. We have the box plus 11 equals 20. So this is really x plus 11 equals 20. And I want to know, how do I find x? We want to make x all by itself. So if you think about it, I'm going to go, okay, 20 counters. I'm going to do 4 rows of 5 counters. So I'm making an array here. I'm hoping to do this to try and help you make sense of how algebra works. If you were in kindergarten, I'd say, okay, we have our 20 counters and we know about 11 of them. So we're going to get rid of those 11 counters to figure out how many counters we aren't thinking about. And then I would have counted them and gone, oh, there are 9 counters left. So 9 must go in the box. I know that 9 plus 11 is 20. Well, in algebra, we don't quite put it this simply, although I want you still to understand that algebra is just this simple. What we would do is we'd say, okay, I'm going to take 11 away from this side to get rid of it so that the x is all by itself. And whatever I do to one side, I have to do to the other. So I'm going to take 11 away from this side. And then I am left with x equals 9. Think of it like a scale. If I have in my scale 20 things on this side and 11 things on this side plus an unknown box, if I take 11 things from this side, all of a sudden this side's going to go way up and this side's going to go way down. So we have to keep them balanced by if we take 11 from this side, we also have to take 11 from this side to make sure that they weigh exactly the same. And when we do that, we discover that we've taken 11 from this side, but we've left 9 things there. That must be the weight of my imaginary box. So those are things to think about with algebra. Algebra is really about how do I keep things balanced? So I gave you a couple of different ways to think about that. Number 6, these 4 cubes were placed in a bag. What is the probability that the dark one would be pulled out of the bag first? This is 1 out of 4 chance. Remember I called this a quarter in Math Minute number 13? That would be the same as 25% chance. Number 7, we're using the bar graph to the right. We have A, B, and C. Which of the following statements is or are true about the graph? Is A plus B equal to 50? Well, A, it looks like is 20, and B, it looks like is 30. Last I checked, 20 plus 30 is 50. This is true about our graph. C is half of B. Well, C is 60. Is 60 half of 30? No, that's not true. B is 30 is half of 60, but not the other way around. So we know it's not B. B is more than A. I can just look and see that B is taller than A. So C is also true. We have A and C. For number 8, we have A plus B plus C. So 20 plus 30 is 50 plus 60 is all equal to 110. That's closest to 50? No. 100? Oh, that's pretty close to 100. Is it closer to 200? No. So we know it's closest to B, 100. Change to decimal form. So I'm going to just read this. I have 2 and a half. 2 is my whole number, and is always represented by a decimal point. 1/2. 1/2 is what we call a benchmark decimal. 1/2 is always represented by 5/10. So 2 and 1/2 is 2 and 5/10. 3 and 1/4. So we have 3 and 1/4. Remember that 1/4 is a quarter. So that's 25 cents. So if I had $3.25, I would literally have 3 and 1/4 or 25 cents, $3.25. 20 and a half, I have 20. And again, if I had half a dollar, that would be 50 cents or 5/10. Number 10, these look like fractions. They're also actually division problems. So 20 divided by 4 is 5. 30 divided by 5 is 6. And 40 divided by 8 is 5. All right, I hope you were successful with that one. See you tomorrow for Math Minute number 15.